I'd like to consider the caustic curve formed by the reflections of parallel rays hitting a parabola, but the parallel rays are not uh, themselves parallel to the axis. First, we'll look at a pair of parallel rays hitting two different points on the parabola. This is the focus of the parabola here. Now, I'm going to put points at x coordinate t and at x coordinate t plus h. I'm then going to draw a pair of oblique parallel lines touching these points. We're going to change the color of these lines because just so we know what's what in our diagram. Make them parallel, and then we'll reflect them in the tangents at the respective points. Now, what we're interested in is the intersection of the reflected lines, because as we shrink h down to zero, in the limit, that is the point that is going to be sitting on the caustic. I'm going to first put an angle theta between the parallel pair of lines and the axis, the y-axis. And then we'd like to have a look at the locus of the intersection as theta changes. Well, let's have a look at the angle between those two reflected lines. If we look at it carefully, we see that there is no theta there. The angle is constant for any theta. That tells us that the resulting locus will be a circle. And in fact, it's a circle through the points on the parabola, points B and C, and through the focus A. So if we reduce h down towards zero, in the limit, we're going to see that that circle becomes the circle through the focus, through the point on the parabola, tangential to the tangent to the parabola at that point. So I'm going to just start off there. There's my point on the parabola. Here's my circle. Goes through the focus, goes through the point of the parabola, and is tangential. So now, if light comes in vertically, it's going to reflect at this point B to the focus A. If it comes in horizontally, however, it's going to reflect at a right angle. And we see, of course, because that's a 90-degree angle, that is a diameter of the circle. But if we take the locus of D as t changes, so as we run t up and down the parabola, make it go from -1 to 1, then the locus of D is our caustic. There it is. Yeah, it looks like that. Well, what happens if we're at an angle other than 90 degrees? So the light coming in truly obliquely, it can change this 90-degree angle to theta. In the meantime, our curve has gone wild, but there we go. We're back at theta. Theta has a value at the moment of 90 degrees, but we can change it and observe that the caustic rotates and shrinks right down to the focus.